All right, this live streaming has been started. Welcome to this live videos. You request me to do a playlist on backtracking and recursion. This is my second video of this playlist. Now I'm going to solve a popular backtracking problem, permutation of string. So let's start solving this problem. So let's assume that we're given a string. We're given a string s equals to a, b, c. What are the permutation of this string? Can you tell me the permutation of this string? Please comment in this video. Okay, the permutation of these strings, how many permutations of the strings are there? There is 3 factorials. 1 times 2 times 3 equals to 6. So we will have total 6 permutations of this string. Total 6 unique permutation. Let me find out that. So first A, B, C, then A, C, B, then B, A, C, B, C, A, C, A, B, C, B, A. These are the 6 permutations of these strings. We have to find out the unique permutations of these strings. As of now, we're going to solve this problem and we're going to assume that we have all unique character in our string, and we're given only alphabet letter, English alphabet from A to Z, or and from A to Z. Now let's see how to solve this problem. And also we assume that the given string are lexicographically sorted. So we will have something like this ABC. We will not have input something like this ACB. Okay, the given string we're assuming that the given string contains all unique character and lexicographically sorted. So lexicographically sorted. Let me show you how to solve this problem. Then we will see for duplicates characters. If we have duplicates character in the string. First, let me solve this problem for non-duplicates. We have no duplicates in the given string. Let me show you how to solve this problem using backtracking algorithm. All right, let's assume we're given a string A, B, C. If you're watching this video, please pay your full attention here. This is going to be super important. We have here this string A, B, C. So we have no permutations. We will write down our permutations right here. Permutations. So first we have here A, then B, then C. So which element we're going to choose first, or which character I'm going to choose first? I'm going to choose the first character. So A. If we choose A, we're left with B and C. So here we have B and C. So we chose A, we have here B and C. So BC. Here we have another choice. We can choose here B instead. If we choose here B, we're left with AC. If we choose here C, we're left with. If we choose C, we're left with AB. We'll be doing this in DFS manner. First, we'll go as far as possible in the left subtree. So we'll back to this. As of now, we're gonna just move to the left subtree. Now let's move to the left. From here, we're going to select the first character, that is B. And here we have selected A. Now here let's select B, so we will have here B. So in this path we see we have two characters, A and B. In this state, actually we will append this string to this or we'll append this character to this character, so we will have here something like this AB. But for sake of understanding, let's assume we're just going to add here B. So we're taking here B, so it's easy to visualize. So here we have B, we selected B. So in this path we have AB. When we're saying what are the permutations up until this point, and that is AB. Now if we select here B, we are left with only C. So here let's select C. If we select C, we're left with empty string. When we're left with empty string, what we will do, we will add this string ABC. We will have here something like this. Here we'll have AB, and here we'll have ABC, something like this. Don't be confused. So let's leave it like this, no problem. If I leave it like just A, B, and C, you might be confused. So let's add here this A, B. Let's append the selected character. So we'll have here A, B, C. We're appending this C at the end of our string A, B. Okay, so here if we selected C, we will have here A, B, C, and we're left with empty string. When we're left with empty string, what we will do, we will add these permutations to our list of permutations. So let's add here A, B, C. Now there is no way to go. This is our empty string. So here we're left with no character. We have already selected C. So let's backtrack here. So when we backtrack here, we have selected here B. But now we are done by selecting B. Now let's move to see the next character, which is C. If we select C here, so we have here this choice C. If we select here C, let's append C to the A, to the next of A, to the end of this string A. So we will have here AC. Now what we're left with, we're left with so we have selected here C, so we are left with B, right? We have selected C, so we are left with the rest of the string here, that is a B. And here we see that we have only B, so we can here choose this B. If we choose this B, I'm going to just add it to the string. So we will have here A, C, B, and here empty string. If we have empty string, if we find out empty string, we will add the string to our permutation list. So here we have A, C, B. If you guys have any question, please ask your question. Comment your questions. I'll try to answer that. Let me check it on my phone whether you were asking a new question or not. If you have any question, please ask your question. I'm glad to answer them. There is no question actually. If you have any question, guys, post your question here. Do you have any question? Okay, I commented from my different account, no problem. So here we are left with nothing. So we have empty string, so nothing to do here. Here we have B. We have already selected B. There is no other choice. So let's backtrack here. We have selected C, B. We have already selected B. We have already selected C. So let's now backtrack. Let's move to this string. Now we have our choice. We have our second choice. If we select here B, we have nothing actually. Initially our permutation is empty. Now if we select here B, then we can append it to this empty string. So here we will have B. So we have selected here B. If we select B, we're left with the character A and C. So we will have here AC. Again, here we will have two choices. First, let's go to the left subtree as far as possible. So here, what I want to choose, I'm going to choose A. If we choose A, let's add A at the end of this. So we will have here BA. Then we're left with here C. Let's select here this C. So let's add it to the end, BAC. So here we're selecting B and here C. So we're left with empty string. So we're done, and there is nothing to do. We have no more choice here. We have find out BAC of line 3 and here empty string. So let's add that to our permutation list, BAC. Please pay your full attention here. We have another problem where we might have duplicates. So here, now let's assume that, okay, so here we have selected C. Let's backtrack. We have selected A already. Now let's select here C. If we select here C, we will add C to the end. So we have a recursion called state, recursion state. In the recursion state, we will have the access to these strings. When you backtrack here, we have the access to these strings. Okay. When you moved here, we have access to this string. So we have just appended C. Now here we have access of B. So we'll just add to the next of a B, just this character C. So we will have something like this BC. Now we're left with A. Now here we have only one choice. If we select A here, what we will get? We will get BCA. So here we will get empty string if we select A. Now we are done. We find out another. Another permutations. Let's backtrack. We have no more choice here. Let's backtrack. We have already selected A and C. We're done. Now we have here, we say selected A and we have selected B. Now we have the third choice, which is a C. Let's select here C. If we select here C, initially our permutation is empty. So we'll just append this C to the next of our empty string. So we get here C. We'll see this when we'll implement our code. Now here, what I'm going to do, I'm going to find out the character, the unselected character. We selected C, so we're left with A and B. So we have here AB. Now here again we have two choices. If we select here A, then we will have CA. So we're left with B. Then again, if we select here B, then we will have CAB. So let's add it right here. CAB, empty string. There is no choice. There is no choice here, and we have second choice here actually. So let's add B to the next of C. So CB, and here at the end of right here, what I'm gonna do, I'm gonna just add here A, and we have CB, and we have here A. We have just one choice. If we select here A, so we will get CBA. Then we get here empty string. So let's add CBA right here. Now we have no choice. Here we have no more choice. Here again we have no more choice. We are done. We find out our permutations. These are the permutation that we have to return. We know that of length 3, the permutations are 6. We have a total 6 permutations. So we have solved this problem successfully. I hope you have understood this problem in a very high level. Still, if you guys have any questions, please ask your questions in the replay forum or in the live chat. I'm looking at the live chat. If I saw any questions, I'll be glad to answer your question. Actually, there is no questions I saw. All right, I think you're understanding. Let's move to the next topic. Let's move to the next. Okay, we can now implement this algorithm. I'm just waiting for your response, guys. If you have any question, please ask your questions. I'm ready to answer your question. Actually, there is no question I found so far. All right, so no problem. There is no questions, no problem. What are the time and space complexity of this? We will talk about time and space complexity later. Now let's implement this algorithm. Actually, I saw no comment, no response from you guys. That's not good for me. If I don't see any response from you, I can't follow. I can't follow anyway. I have to stop this playlist. If you respond me, then I can move on. Okay, no problem. One people are watching this live. I'm happy with that. So now let me analyze the time and space complexity. The space complexity is straightforward. In our recursion call stack, we might have at most n items. So the space complexity is O of n. This is our space complexity. Now, what are the time complexity of this algorithm? Can you guys tell me what is the time complexity of this algorithm? If you are watching this video, can you tell me what is the time complexity? Okay, here we have a total n characters, and we have to find out the permutations of length 3. How many permutations? We have to find out in permutations. So for each permutations, for each 1, for every single one we have to do a permutations, right? So we have to find out a permutation. That time complexity would be n times n factorial. So the time complexity is n times n factorials. I hope you understood this with explanations. If you have any question, guys, you can ask here. Now let me implement this algorithm using Java. Then I will show you how to solve this problem when we face duplicates. All right, let me open my IntelliJ IDE. Let me create here a string. A string str equals to abc. Let's use here just abc. And here I'm going to create our list. So list of string. We'll have a string, and let's call it list equals to new array list. This is a part of collections library. So here we have to import collection. So let's import it here. Import java.util. I'm going to import here everything. Now we have to now we have to implement our code. Let's call a function here. Let's call a function dfs. The function takes our string, then initially our permutation is empty, then we have to provide this list. This function will construct this list. So I'm sorry, here I should have uppercase L. Now here I'm going to just return the list. Now let me implement this function dfs. Alright, so what it is saying, return. Okay, I will see this. First let me implement. So here let's implement the function public static void, return type is void dfs. It takes two string str and a string permutations and list of string. So string, let's call it list. This list will store all the permutations. Now first we have to check our base case. If we saw the length of our string is empty, or if our string became empty, what we will do, we'll add the permutation to our list. So if the length is 0, we'll just add the permutation to our list. So let's start add our current permutation. Now here we have our recursion function. Int I equals to 0, I less than string dot length, then I plus plus. Right inside here, let's get our current character. So current ch equals to str dot char at I. So we get here current character, something like this. Now what I'm going to do, I'm going to remove our current characters from our string. So how we can do that? We can do it in many different ways. I'm going to use here just a substring method. So a string, let's call it temp strings, or by removing the characters, we'll have this temp string. So let's remove our current character from our string. So str.substring, we're going to just get our from 0 to 0. So it will remove the from 0 to I. It will remove the first our current characters. Plus str.substring I plus 1. It will get the rest of the string. Okay, so if initially it is 0, so it will takes nothing here, and it will just skip by the first character for first iteration. Something like this. This is pretty straightforward. The language specific code here. Now here we're gonna just provide 3 parameter. Str changed to temp, and our perm we have to add to perm our current character, and we have to provide the list, whatever the list is. And this is all about it. This is our algorithms. This is our algorithm. I hope you understood it. Now here at the end, I'm going to just return this list. Oh, here actually, I'm sorry for that. This is our main function. Here we can't return. I'm so sorry guys here for this. This is my bad. Now I'm going to just print whatever we have in our list. So let's get the list. So we have string. So string is in list. Just print it here. So I'm going to just print it the string. Let's run this code. I think it should work, and this is my algorithm for this. All right, these are the 6 permutations. We just saw it. Let me find out how many people are watching this video. Oh, my bad. This is my bad luck here. There is no viewers. I'm so sorry. That's why I want to. Should I explain that? Should I solve these problems? These problems consist of lowercase or uppercase English alphabet and lexicographically sorted order. We have to write on the permutations. You guys have no. Attention to this video. Just 1 people watching now, guys. Are you guys watching this video? Please let me know in the comment. Should I follow up these questions? If I have duplicates, how can I solve these questions? If you want to see the solutions, please comment. I will explain the solutions and I will show you everything in for that. Oh, okay, let's talk to you guys. Are you guys here watching this video? Should I follow it? I don't know because there is no viewer. I guess. Okay, let me solve these questions anyway. I think it will increase the viewers day by day. Anyway, now let's start this problem. We have to find out permutations of a given string. Given a string S, the task is to print all unique permutations of the given string in lexicographically sorted order. This is the problem. If you're given ABC, you have to write in these 6 strings, and if you're given ABST, you have to write in this 24 permutations. This it might have duplicates. So let's see how to solve this problem when you have duplicates. Let me finish it quickly, and I think the video length increasing too much. Here we have, let's assume A, and B. So what are the permutations? First, let me find out the permutation. Let's do a little math. So 3 factorial divided the common are 2. So equals to 3 times 2 factorial divided 2 factorial. This to count. So we have 3. So we have total 3 permutations. Let me find out the 3 permutation here. AAB. This is one kind of permutation. We have ABA. This is one permutations, and we have BAA. These are the 3 permutations we have to write in. That's all. Pretty simple, right? Now, how to solve these questions when you have duplicates? This is pretty straightforward. We have to do little tweaks to our previous solutions. If you understood the previous solution, this is going to be pretty easy for you. All right, so let's draw here our decision tree. This is called kind of decision tree, right? So first, I'm going to select A. When you selected A, this is our function call. So in this recursive state, we will have a set data structure, or somehow we'll mark that we have selected the character A. Okay, so from each recursive function call state, if we select here A, we're left with AB. Again, if we select here A, we're left with AB. You clearly saw that if we select the same character twice, we will have it will produce no matter what the input is. First thing what I have to do, we have to sort the given string in lexicographically order. We have to sort that. That's because we want to find out the permutation in sorted order or lexicographically order. So in order to do that, first thing what we have to do, we have to we have to detect that if we select the element here, we cannot select the same element in here. If we select the same element in this decision tree, so we generally will have here 3 choices, A, and B, right? But here we cannot have this choice A. If we choose here A, then what we will have? We will have again AV, and you saw that here we have already AV. So it will going to produce the duplicates permutation that are not allowed. We cannot produce a duplicate permutations. Hope you're understanding this term here. So if we have a duplicate, we will somehow detect that we have already selected. We cannot select it at this recursive state or at these positions the same element twice. If we select twice, we will have duplicates for sure. So we have to handle that. How we can handle that? We will mark it somehow. So here, if we have in each state, if you have a set data structure and if you store this A, here you have already selected all the selected item. Then you can check if it not selected when you move to this character. If it is not selected previously in this state, then we can select it, otherwise we can't select it. This is the core intention to solve this problem with a duplicate. So let me finish it off here. So first we have here A. So we marked A, we have selected. Now we have AB here. So here let's select A. We get here AA. We just appended this A to A. So here we are left with just B. Now let's select here B. If we select B, let's mark it, we select it. Now here what I'm going to do is that I am going to add this A to the end. So we get here AAB. Pretty simple. We get here empty string. We have selected B. So we are done. So let's add this to our permutation list, right? There is no more choice right here. So let's backtrack here. Now let's move to this. Does B is selected in this state already? No, B is not selected. So what I'm going to do, if B is not selected, I am going to just make this choice here. That's it. Pretty simple. So we have previously A, so let's append it to B. This B to the A. So we're left with now A. Now here we have just only one A, so we can select this guy here. So let's just add A to this, append it, so we get ABA. We get empty string, so let's add this to our list here. That's it, pretty simple. So there is no choice. And here we have selected this guy and this guy. We'll have something like a set data structure right here. Whether we can check does we select it or not. And there is no more choice here, so we'll just backtrack here. Now we have here the next character A, and in our set data structure we'll store this A here, right? If it is already selected, we cannot select it anymore. Why is that? Because if we select here, then we will have here AB that will produce the duplicate answer, the duplicate permutation. To prevent that, we want to use a set data structure in every single state. I hope you are understanding. We have to keep track somehow that we have already visited. So now here I'm going to choose B. So we're left with AA. It is allowed, no problem. So we have selected A. We cannot select A and B. We have again selected a B here. So in our set we have AB now. And here we have A. So let's select here A. Okay, so let me show you how it looks, right? So we have selected here A. So what are we left with? So we'll have here just let's append BA here. We are left with B A. Sorry, let's select it. So we'll get here BAA. We'll get empty string. So let's add that right here. And here no more choice. We'll have a set only we have this one item, no problem. So let's move go off here. We'll have a set, we have selected A. Then we have A, next choice A. But we cannot make the choice because if we made here the choice, we'll have the duplicate answer. We have already selected A from this state. So we cannot select it anymore. Just skip it. Let's move to the next, there is nothing. So we're done. Let's move to here. Now we have the next character, there is nothing, we're out of bound. So we're done. We are done. This is the solution to this problem. I hope you have understood this explanation in a very high level. If you guys are watching this video, please comment on this video if you have any questions or if you have any issue understanding these video explanations. I'm ready to help. And I want to make sure this channel is stand out on the crowd on the YouTube platform, so you can get I can give you most out of it. Actually, my courses and videos are underrated, I think so. And if you guys help me to grow, then it's possible. And if you want me to grow, please subscribe. If you're watching this video on the channel, please subscribe to the channel and stay tuned with Tech Barik. So what are the time complexity? Time complexity is straightforward actually. If you have n number of duplicate elements, so the time complexity would be n times n factorial. You have to find out n factorial here. The n factorial permutations, that's why it is n factorial times n times n factorial, and the space complexity is O of n, because we the stack will takes at most the height of our tree, of our decision tree. That's why it's take O of n time complexity. Hope you have understood this video explanation. Now let me solve this problem on Geeks for Geeks, so you will have a full understanding of this explanation. Let me go to Geeks for Geeks. All right, this is the problem link. You can visit it. Now let me solve it. All right, now Right, so let me go to the full screen so it will help us. Okay, so this is our problem. We're given a string. We have to find out unique permutation of the given string in lexicographically sorted order. All right, so let's see how we can do that. First thing, let's sort the given string. The string can be sorted, or also it can be unsorted. So first thing what we have to do, we have to sort the string. So let's sort our string. So first, we cannot mutate the string. We know that we cannot do operation on a string. So what I'm gonna do that we cannot update the string. So we have to first convert the string into a character array. So let's create here char array. So character, let's call it array equals to is dot to char array. I'm going to converting this string to a character array. Now I am going to sort this array. This is a built-in method, so it will sort the array. We don't have to worry about that. And we have to now reconstruct the string. Let's call it. Let's create here another string. A string str equals to new string from our given array. So it will construct the strings from the given array. We have to, don't worry about it. If this string is something like this, A, C, B, it will be sorted in this order, A, B, C. That's it. Now let's see. Let's implement our algorithm here. We have to return the list of strings, list of permutation. So list a string, a list equals to new array list. Okay. Now what I'm going to do right below here, I'm going to call the function DFS. Let's call it DFS, or you can call permutation function, constant permutation, whatever you would like to do. I wanna call it DFS because we're just solving this problem in DFS manner, in depth first manner. We're moving to one direction or moving to the left direction as far as possible. So I'm gonna call it DFS. So first thing, what I have to do, we have to provide the string, the given string, and our permutation empty. Initially our current permutation is empty, and the list will construct we'll add the this is kind of a pointer. We're just sending this list to a function, and we'll add the permutation to this list, and then we can just simply return this list. I'm sorry, it's a little typo here. Now let's implement our DFS function. So public static void, the return type is void, and let's call it DFS, and it takes two parameters, string str, string permutation, we can name it whatever we want, and then here list, and inside a string, and right here list. This is our function. So what is the base case? If our string is empty, if str.length equals to empty string, if our string is empty, what I'm going to do, I am going to add the current permutation to our list. It means that we have a valid permutation in this variable string. So list.add list.add perm. And right below here, what I'm going to do, I'm going to run a loop. So this is our base code of this recursive function, and this is going to be the recursive case, we can say. So I equals to 0, I less than str.length, and I plus plus. Right inside here, what I'm going to do, I am going to right inside here, before that, first we have to keep track in is state of our recursive function call. We'll have a set for is function call. We'll have a state. So let's we'll have a state. In the state, we will have a set data structure. In here, we will store the character. The character, if the character has been taken or chosen, then we cannot choose in the second times in the same state, from the same state, right? So set equals to new hash set. This is our hash set. I'm using your Java programming. In your programming language, it might be dictionaries or any other stuff like that. I don't care. I don't know. Might be you have a data structure, something like set. Anyway. Now right inside here, let's get the current character. So char siege equals to str.char at I. So here what I'm going to do, I am going to remove our current character. Just remove our current character from our string. So let's do that. A string, it can be done in many different ways, but I'm going to use substring method. So str.substring from 0 to I. Initially, if I equals to 0, it will take nothing because it takes from 0 to the index, the end index -1. So it will take nothing here, empty string plus, and we'll skip our first string for first iterations, and for every iteration it will just exclude our current character from the string. So str dot substring and I+1, from I+1 all the way to the end. Alright, this is our questions. We can do this inside our conditions. If I'm gonna check if it does not contains in our current state, if our current character does not contains, if it contains, we are not going to do that. If it contains, we're not going to call the function recursive function, or we're not going to choose that. We'll just skip it. Right, and here what I'm going to do is that right here I'm going to call the function DFS. So we have a modified string here, so temp, it will be modified excluding our current character, and here we have to add our current character to this perm. So perm dot permutation or perm dot ch, and we have to provide the list, whatever it is. And at the end, right below here, what I'm going to do is that I'm going to just add our current character to our set if we have already chosen it. So set dot add, this is kind of a recursive code. If you are new to recursions, it might be a little bit difficult for you, but if you look at the diagram or the presentation I just showed you, you will have a pretty good understanding, I think so. Still, if you have any question about this code or about the explanation of this video, you can ask any question in the live chat forum. You can comment. I'm ready to help. There is no comment actually, so I am going to just finish it here. Let me check if there is any comment. First, let me finish it, and let's just add our current character right here. Actually, we're done with our algorithm. This is our core algorithms. Okay, now let me test this code here, if it's okay or not. If there's something goes wrong, I will explain that to you. Let me check it whether it is working or not. Okay, so st.length equals to, oh my god, I'm so sorry guys, here it's my bad here. If it's not empty string, we're checking the length. We can stick it with empty string, but I'm gonna check the length here. So let's compile and run it. If I check string, we will not have correct answer always. That's because strings are object in Java. So for checking object, you have to use a different method, equals or something like that. Just check here the length anyway. So it is accepted, compilation successful. Now let's submit it. I think it will be accepted. Let me check whether it is. Okay, it passed all the test cases, and this is how I think this is how we can solve this question. This is a pretty straightforward questions, and this is a very interesting questions, and you have to understand, you have to solve this question in order to build your solid foundation on recursions. And you know that dynamic programming is an art of recursion. If you know the art of recursions, you can do very good. You can be very efficient in dynamic programming. So before moving to dynamic programming series, first you have to be master of recursions. Master the art of recursions, then the dynamic programming would be very easy for you, I think so. And yeah guys, this is all about this video. And I see there are less people watching this live now. That's because of the time zone maybe effect. For the time zone maybe the viewers are not now online. I don't know. Anyway, let me know when I should go live. Just comment in this video. I'll try to go to the live at that times. And first, I chose this series. In this series, I'm gonna just solve questions on recursion and backtracking, and it will give you a solid understanding in backtracking. And yeah, guys, thanks for watching this video, and thanks for joining in this live. Thank you very much. I will see you very soon. Till then, take care.